Hello, welcome to the second video where I'll be talking about balancing chemical reactions and dimensional analysis. So let's first start out with our first concept, balancing chemical equations. Below I've written down the unbalanced combustion reaction of methane, CH4. Now, the goal of balancing chemical reactions is to make sure that we have the same amount of each element on the reactant side as with the same amount of each element on the product side. So first, let's just dive right in. Let's look at our first element, carbon. On the left side, the reactant side, we only have one carbon. On the product side, we also only have one carbon. To be more specific, that means 1 mole of carbon and 1 mole of carbon, respectively. So let's move on to our next element, hydrogen. On the reactant side, we have 4 hydrogens. This is because we have 4 moles of hydrogen in CH4. So that's why we have 4 hydrogen. Continuing on with that logic, if we look over to our product side, we only have 2 moles of hydrogen, or 2H. So now we see that there is a discrepancy between the amount of hydrogen on both sides. One way that we can fix it is by making the 2H into a 4H on the product side. If we can somehow change this to 4, we would be balanced. So we can change this number 2 into 4 by just adding a stoichiometric coefficient of 2 to the H2O molecule. Now, this basically implies that we're getting 2 molecules of H2O in every combustion reaction. And whenever you have 2 molecules of H2O, that means for each molecule you have 2 H's. So if you have 2 of those molecules, then in total you will have 4H. Now we're balanced for hydrogen. Let's go on to oxygen. For oxygen, we have 2 O's on the reactant side because of the O2. On the product side, we have 2 moles from the CO2, 2 moles of oxygen from the CO2, plus 2 moles of oxygen from the 2H2O. So in total, that means that we have 4 oxygen on the product side. So now we can do the same thing that we did for the hydrogen. We can add a stoichiometric coefficient except to the reactant side now and make that a 2O2. So now in total we have, instead of 2O on the reactant side, we now have 4O on the reactant side. Now we're completely balanced. We have the same amount of oxygen, hydrogen, and carbon on both sides. So now let's go over dimensional analysis. Dimensional analysis in simple terms says if I have a certain amount of reactant, then how much product will I get out of that certain amount of reactant? And same thing, vice versa, applies with if I get a certain amount of product from a reaction, then how much reactant did I have to use in order to get that amount of product? So let's do a quick example to see what I mean. So let's say we're told that in a lab we utilized only 4 grams of CH4. We have an unlimited amount of oxygen to our disposal. And before we complete any reaction, we need to predict how much H2O am I going to get? How much water am I going to get in grams? So how many grams of H2O will I get out of this? And this is where dimensional analysis comes in handy. So first, we need to convert between grams of CH4 to moles of CH4. The goal of dimensional analysis is to go from grams of CH4 all the way to grams of H2O. So the first step, like I said earlier, is we have 4 grams of CH4, and we need to convert between 1 mole of CH4 to grams of CH4. So for every mole of CH4, there are 16 grams CH4. Let me write that for a little bit better. Next, we need to go from moles of CH4 to moles of H2O. And the way we do that is by looking at our combustion reaction right here. So we can see that for every 1 mole of CH4, so for every 1 mole of CH4, I get 2 moles of H2O. So I'm going to write 2 moles H2O on top right here. Next, now that we have moles of H2O, all we need to do is go from moles of H2O to grams of H2O. So what I'm going to do is, I know that by looking at the periodic table, there are 18 grams of H2O for every 1 mole of water. Next, all I need to do is, I need to multiply all these terms that I wrote down, and we'll see how we go from grams of CH4 to grams of H2O. So when I multiply, starting with 4 grams of CH4, I see that right here, the grams of CH4 cancels out with the grams of CH4 that I wrote down below. Next, once I do that, I can see that the moles of CH4 also cancels out with the moles of CH4 that I wrote down here. And finally, the mole of H2O cancels out with this unit, mole of H2O, below. And next, all I'm left with is grams of H2O, which is exactly what we want right here. So now, what I need to do is, I need to multiply all these numbers together, and what I get from this multiplication is, in total, I get 9 grams of H2O. And so that's our answer. And that is a simple dimensional analysis for the combustion reaction of methane.